Hi everyone. Previous classes we have already learned that the electric field lines and their properties. Today in this video we are going to see the dipole. What do you mean by dipole? Dipole is nothing but two equal and opposite charges separated by a finite distance is called dipole. As we already said, a point A, a negative charge Q is placed, and at the point B, a positive charge Q is placed. They are separated by a distance to A. The axis of this dipole is the line joining these 2 point charges, negative Q and positive Q. And the midpoint of these 2 charges may be point taken as O. O is the center of the dipole. Then when we describe about the dipole, then another terms come into play, that is the dipole moment. Then what do you mean by dipole moment? An electric dipole is characterized by dipole moment. The dipole moment of an electric charge is given by the product of either the charge constituting the dipole and the distance between them. Dipole moment is a vector quantity whose direction is from the negative charge to the positive charge. Dipole moment is denoted by a letter P. Since it is a vector quantity, an arrow mark is also there. So as I said, the dipole moment is the product of either the charge and the distance between them. So we can write the dipole moment P is equal to, and the charge is Q, and into the distance between them is 2A. That can be written as 2AQ. It is the expression for the dipole moment. Then what is the physical significance of dipole moment? Most of the molecules, we know that the center of a positive charge is coincide with the center of the negative charge. So therefore, in such molecules, the dipole moment is 0. So then, these molecules are called non-polar molecules. For example, H2, O2, carbon dioxide, CH4, etc. are the examples of non-polar molecules. In some other molecules, the center of the positive charge does not coincide with the center of the negative charge. Then there will be they are separated by a distance between them. Therefore, the magnitude of the dipole moment is not 0 in such molecules. Then such molecules are called polar molecules. The common example, we know that example of polar molecules, they are H2O. Water molecule is a polar molecule. Hydrochloric acid is an example of a polar molecules. The next is the field of an electric dipole. The electric field due to an electric dipole at any point on the space can be found by the Coulomb's law and the superposition principle. If electric field at any point P is to be obtained, we need to find electric field produced by positive charge at P due to negative charge, and electric field produced by the negative charge Q at point P due to the positive charge. And then the resultant electric field E will be, what will be the resultant electric field? that will be the vector sum of electric field produced by the positive charge at point P due to the negative charge, and the electric field produced by the negative charge at P due to the positive charge. And in order to find out the electric field produced by an electric dipole at a point P, there are two special cases in order to find out the electric field produced by an electric dipole. The first one is electric field at a point on the axial line of the electric dipole, and second one is the electric field at the equatorial line of the electric dipole. These are the two cases, and first let us see the first case. So as we said earlier, there is at the point A negative charge is kept, at the point B a positive charge Q is kept, and we take a point on this axial line, okay, P. We take a point P on the axial line of the electric dipole. Okay. Now the distance between these charges, positive and negative charge, is 2a, and this is the midpoint of the electric dipole O. Okay, and this is 2a. The direction of the dipole moment towards this direction, and the electric field produced by the charge Q, positive Q, that is the electric field produced by the charge Q, that is plus Q, and again another, both charges produce an electric field, and again the electric field produced by the negative charge minus Q also there. The distance between the center point or midpoint and the P, that is taken as R. This distance is taken as R. So we have an electric dipole and it has an electric dipole moment, and now we are going to calculate the magnitude of the electric field produced by the negative charge and the positive charge. The magnitude of the electric field produced by the negative charge EQ. So this is we are going to find out the magnitude of the electric field produced by the negative charge EQ is equal to, as you know that the electric field produced by a charge of an electric dipole can be found by using the Coulomb's law. So as per the Coulomb's law 1 by 4 pi epsilon 0 into, then the charge associated here is the charge Q, then there is a charge Q here, then what is the distance between them? Divided by the charge divided by the square of the distance between them. And what is the distance between them? Here, since the electric field produced by the negative charge is placed at the point A, then to the point P, the distance between them is AP. So we write AP square, that is equal to 1 by 4 pi epsilon 0 into Q divided by, then what is the distance AP square? AP is what? That is 2A, okay, and 2A at this distance, okay, from A to B is 2A and B to P is, O to P is R. Then how we can calculate here the distance between them is from O to P, the distance is R, and R starts from where? The point O. Then again the half of the 2A, half of 2A is what? A. So the distance can be written as R plus A square. Okay. The distance R plus half of 2A is A. The field E minus Q is directed in which direction? Directed PBA direction. Okay, that means it starts from the P towards this direction. That is the direction of the directed along PBA. Now this is equal to. Now let us find the electric field produced by the positive charge due to the negative charge. So the magnitude of the electric field produced by the positive charge is equal to, that is 1 by 4 pi epsilon 0 into Q. Here the charge is what? Q, same charge. Okay, since both are equal in magnitude but opposite. Okay, Q divided by, and what is the distance between them? The distance between the positive charge and P, that is R. Okay, O to B is A, that is half of 2A, that is A. Then O to P is R, that means from R, if we subtract the distance A, then we will get the distance between B and P. So we will write R minus A square. Okay, that is the magnitude of the electric field produced by the positive charge. This is directed along in which direction? A, B, P, towards this direction. Okay. The resultant electric field is the vector sum of the magnitude of the electric field produced by these two charges. Okay. So the net charge E can be written as, that is equal to magnitude of electric charge produced by plus magnitude of the negative charge. Okay, and this is the vector sum of these two charges will give the net result or resultant electric field produced by this point P. And obviously we explain that the electric field produced by these two charges are opposite in direction. Since they are opposite in direction, so definitely the charge, magnitude of the charge produced by the positive charge will be greater than the magnitude of the electric field produced by the negative charge. So we may say that, we may write as magnitude of the electric field produced by the positive charge is greater than the magnitude of the electric field produced by the negative charge. That is equal to E plus Q minus electric field produced by the negative charge Q. Substitute the values of these two, then we will get E is equal to here 1 by 4 pi epsilon 0 is common. Then 1 by 4 pi epsilon 0 is common in both equations. Again, what is common? Q also common. So this will be 1 into Q. Q into 4 pi Q divided by 4 pi epsilon 0 into. Now what is remaining there? 1 divided by R plus A square. Minus 1 divided by R minus A square. Now Q divided by 4 pi epsilon 0 into. If we take the LCM, R1 plus A square into R minus A square. And write R minus A square whole square. R square, A square, whole square. Then, and numerator will come as R plus A square minus R minus A square. That is equal to Q divided by 4 pi epsilon 0 into, and this then can be expanded, and when we expand this, what we get is in the form of a plus b whole square and a minus b whole square. When you expand this 2 times, you can write r square plus a square plus 2ar again minus r square plus a square minus 2ar divided by r square minus a square whole square. Now r square can be cancelled, a square can be cancelled, then 2ar minus plus 2ar. That means what we get? Q divided by 4 pi epsilon 0 into 2 plus 2ar plus 2ar, that is 4ar divided by r square minus a square whole square. Now this can be written as E is equal to 1 by 4 pi epsilon 0 into, and Q can be taken inside, that 4 a q r divided by r square minus a square whole square, that is equal to the equation for dipole moment. P is equal to, we have P is equal to 2aq. So if we write the same equation, E is equal to 1 by 4 pi epsilon 0 into, okay, 2 into 2aq into r divided by r square minus a square whole square. Okay, here 2aq can be written as P. Okay, so now we can rewrite this equation as 1 by 4 pi epsilon 0 into 2 into P r divided by r square minus a square whole square is the expression for the electric field produced at the point P due to on the axial line of the electric dipole.